My name is Stuart Duncan. I'm a master's student in communication and culture here at Ryerson University in Toronto. And as mentioned, I'm going to talk a little bit about how text-to-speech technologies could potentially impact the journalism industry. So in addition, I guess, to being a graduate student here at Ryerson, I've also worked in digital journalism and media production for well over a decade here in Toronto. So most of that has been with the CBC, Canada's public broadcaster. And so I'm able to kind of combine both research and journalism practice, and I really enjoyed that process. During my time in journalism, I've really seen how emerging digital technology has really dramatically changed how we create and distribute our content. I have found that we're much more reliant on digital platforms and technologies to share what we do with audiences. And so with my research generally, and with this paper specifically, I was really motivated to better understand how emergent technologies might offer new opportunities to share important journalism with audiences. So search and social media platforms have really changed how journalism content is consumed and distributed. These platforms, driven by algorithms, automation, and artificial intelligence, have had significant impacts on the information gatekeeping roles of news organizations. And I think particularly younger audiences have turned away from traditional forms of journalism distribution, such as newspapers, television, and radio, and are relying increasingly on social media platforms such as Facebook and Twitter to learn about world events. So in the face of this, I guess a question that I ask myself is, how can news organizations compete and remain relevant? And one possible approach would be to embrace these platforms' adoptions of automated and personalized content distributions. As I imagine has already been discussed today, at its simplest, personalized news examines the past consumption patterns of users, their peers, and people similar to them in an effort to recommend content and products that are most relevant to their interests. Within the field of journalism, research has shown that audiences have a slight preference for news chosen by algorithmic systems based on their past user consumption over editor-chosen stories. This preference for personalization becomes even more pronounced with younger audiences and users that consume news on mobile devices. So my work specifically with this project examines how emerging text-to-speech technologies could be combined with news personalization techniques to deliver automated audio-based news bulletins. So with the creation of BulletinBot, which is a simple automated news bulletin system, my research explores how news organizations could automate elements of the news delivery process and illustrates some of the issues that might surround this approach. Within a radio context, news bulletins are short summaries of important news items, usually featuring a few news items, usually about 30 seconds each in length. Bulletins quickly get listeners up to speed on what is going on in the world. So before we talk about how text-to-speech could automate this work, I wanted to explore its evolution a little bit. Since the introduction of the first text-to-speech systems in the 60s, scientists have strived to create computational systems that synthesize text into audio, which mimics the sound of human voice. The early results of such technologies were often quite overwhelming. While comprehensible, most speech synthesis systems featured kind of robotic and tinny sounded voices that no one would really mistake for human. But advancements in AI-based machine learning and neural network approaches to text-to-speech over the last decade have really ushered in a new era of realistic sounding automated speech. Computing platforms such as IBM Watson, Google Cloud, Amazon AWS, and Microsoft Azure have all introduced very simple and relatively affordable cloud-based implementations of text-to-speech systems. So as the complexity of text-to-speech systems has evolved, academic researchers have focused on the ideal design characteristics of speech synthesis systems and the social issues the use of such systems might present. Not surprisingly, Camber et al. Explained that research has shown that the quality of a synthesized voice has a significant impact on the user experience. Somewhat counterintuitively, Camber et al. Also found that creating a synthesized voice that was too human-like may cause confusion and mismatch expectations among users. Studies have also found that audiences have an affinity for speech that mirrors their own. As speech synthesis becomes more lifelike, concerns have risen about the ethical impacts of its use. Again, Camber and al. Outlined that voice is a powerful medium for persuasion, and in a digital space where fake news has become a growing challenge, putting realistic sounding artificial voices in the hands of bad actors is an issue of concern. Bendel explained that sampling techniques which allow the recreation of voices of individuals without their consent could also allow for the creation of false narratives. Ensuring that digitized voices present a diverse representations of nationalities, genders, languages has also been identified as an important design characteristic of both text-to-speech systems and applications developed with them. Again, Camber and al. Revealed a disheartening confirmation of prior studies which showed that male voices received higher quality ratings than synthesized voices. This and other research shows that the social impacts of text-to-speech technology could be significant, but explorations of their impact within the journalism industry are limited. It is hoped that by continuing to develop the BoltonBot automated news system that was created as part of this project might spur further interest in this research topic from a journalism perspective. Developed using the Python programming language, BoltonBot's personalization approach centers around a pair of article corpora that represent both an article of archived news items, and a collection of articles that a hypothetical user has previously read. And a little bit later on, I'll share the link to the code for this. These news articles have been scraped from the website of the CBC, News, again, the public broadcaster here in Canada, and each corpora and the associated articles data are stored in a separate comma-separated text file. By comparing the corpus of articles that a user has previously read to the larger corpus of all news article, a list of recommended news articles from the news archive are selected. And so in a certain way, this is kind of simulating a typical news approach, a typical news recommendation approach in very simple terms. This approach uses a rather basic but common technique used in information retrieval studies of employing term frequency inverse document frequency measures along cosine similarity calculations to determine the similarity between our user's perceived interests as represented in the user interest corpus to the larger archive of articles. A sample of how this works in broad strokes can be seen in this slide. For similarity measures, the closer the number is to 1, the more similar the article would be to our user's interests. And you can generally see from this slide that it will recommend articles about soccer, as most of the articles that a user would have read are about soccer as well. A simple news bulletin script is created from the top 5 articles that most match the user's interests by combining each article's opening paragraph, which is called the lead, with a small amount of speech synthesis markup language code. This text-based script can also be synthesized into speech using either a text-to-speech conversion library from Python or IBM Watson's paid text-to-speech service for a more realistic voice reproduction. In both cases, the results are saved as an MP3 audio file. So a significant limitation of our system's design is the repurposing of content that was originally not designed to be used in a radio script. Text-to-speech synthesis also occasionally misses some of the nuances of human speech that would be easily handled by a human newsreader. While the cloud-based text-to-speech systems perform better in this regard, the more simplified Python library struggles to understand that, for example, when reading a sports score, a score written as 12-6 should be synthesized as 12-6 rather than 12-6. Human news readers are also more adept at naturally shifting their tone, speed, cadence of their voice, depending on the context of what is being read. For example, while reading the account of a tragic event, a somber tone can be taken, while a more upbeat approach could use, for example, announcing the birth of a child, could be more upbeat. The current design of our prototype synthesizes all scripts with the same tone and sounds, and it's somewhat monotone in nature. Text that employs speech synthesis markup language could replicate some of the human voice shifts in text-to-speech systems, but automating the creation of such scripts could be challenging. Like many automated systems used in journalism, the most effective implementation of our automated news bulletin system would entail a hybrid human-machine approach. A key element of such a hybrid approach could be atomization. Atomization, as explored by Jones and Jones, would see the news stories broken down into the distinct atoms of information, which could then be rebuilt and repurposed in other forms. One atom, for example, could be the key elements of a story, which could be combined to form a brief news summary in a better way than we have done by just grabbing the first paragraph of the article. Even with a simple approach, however, our prototypes show some of the potential of what a more complex implementation of an automated news bulletin system could offer a news organization. One challenge of a radio news bulletins is how, in a short amount of time, to share information that is relevant to a user's interest. One audience member might be more interested in sports, while another may want the latest business news. A personalized approach ensures that content is relevant to audiences and might lead to a longer and more consistent listening time. An automated news bulletin system also allows for on-demand listening. Audiences would no longer need to wait until the top of the hour, for example, for their latest news. Such a system, if it was integrated into a smart speaker, getting a personalized news bulletin could be as simple as saying, "Hey Alexa, what is the latest news?" The move from a traditional scheduled broadcast model to an on-demand listening could open up programming into new audiences whose schedules don't allow for regular listening. From a cost perspective, advances in text-to-speech technologies could allow financially strapped newsrooms to deploy resources dedicated to news reading positions to other areas. The limitations of our basic prototype have also shown how a news organization might have to adapt their processes to implement a truly effective automated news bulletin. By adopting a human-led atomization approach to their news content creation, news organizations could facilitate the repurposing of their content, leading to more novel ways to distribute their journalism. An automated and personalized approach to news delivery, a prototype of which is shown with our news bulletin system, could help journalism workers reach new audiences and provide a level of coverage impossible with human news workers alone. Again, so that's a little bit of the research that I've done thus far. I'll share a link to the GitHub location of the Bulletin bot. And again, thank you for your time, and I look forward to any questions you might have.